chief characteristics of normal distribution, or you can say the properties for normal distribution. As you know that normal distribution showing a curve like this from minus infinity to plus infinity, and this is a symmetrical line, x is equal to mu, and in this case the mean, median and mode, all the three distributions coincide, and the area of this curve is 1, that is unity. Those, and this curve is a bell shaped. All these comes under chief characteristics, that is properties of that. So the graph of normal distribution y is equal to f of x in the xy plane is known as the normal curve. Second one, the curve is bell shaped and symmetrical about the line x is equal to mu. Area under the normal curve represents the total population, and that is unity. So we are focusing about the limits minus infinity to infinity, as in integral form, integral minus infinity to infinity f of x dx is equal to 1. Next, x-axis is an asymptote to the curve. So x-axis means this is an asymptote to the curve, means this is the line. So this is up to this x-axis to the curve. So this line is at this place, the standard normal variate is 0, that is z is equal to 0. Whenever x is equal to mu, then z must be 0. Why? Because z is equal to x minus mu by sigma. This is called as standard normal variate. Next one, the mean, median and mode of the distribution coincide. Normal curve is known as unimodal. So all the three are coincide. So it has only one maximum point. That is only one peak point of the curve. That is called as unimodal. So the curve extends from minus infinity to infinity, and this curve line does not touch the x-axis. That is the important point. Next point, the probability that the normal variate x with mean mu and sigma sd lies between the 2 points x1 and x2 is given as 1 by sigma under root 2 pi and the limits from x1 to x2. So already basically we have the limits minus infinity to infinity, and here we are selecting one of the points, that is x1 and x2. In that we are taking the limits from x1 to x2, remaining as the same in the formula. Next, so those are the properties of normal distribution. So what is the importance of normal distribution? Actually this normal distribution is playing an important role in statistical theory. So this statistical theory based on statistical quality control. So quality control, this shows this word is related to the business. So whenever a company launch a new product, that company should maintain that company should monitor and maintain the quality of that product. So that is one of the applications of normal distribution. So how they can find the quality is good or not? So that is based on the control limits. So that is another concept used in statistical quality control. So this for checking the quality, one of the samples can be taken, and that will be checked by the control limits. Next one, most of the distribution occurring in practice. For example, if you take binomial, Poisson, etc., these are the normal distribution limiting points. So this can be approximated by using normal distribution. Next, since ND, normal distribution, is a limiting case of binomial distribution for exceptionally large numbers, it is applicable, means a large number of values n. It is applicable to many applied problems like kinetic theory of gases, and fluctuations in the magnitude of electric current. These are all the applications to normal distribution. And the next one is, even if a variable is normally distributed, it can sometimes be brought to normal form by simple transformation of the variable. So if it is that will be a variable, and it is converted into normally distributed by transforming the variable. The next one is the proof of all the tests of significance in sampling are based upon the fundamental assumptions that the population from which the samples have been drawn is normal. So I told you, no, this normal distribution is playing a vital role in quality control. So that quality may be controlled by checking the samples from the population, and that is normal. Finally, we conclude that normal distribution are only minor derivatives from the line to the point on probability. So from the line to the point, it is appeared to be good model for data. So normal distribution are only minor deviations. That's why the areas from the x1 to x2 or minor deviation, and that can be concluded with this applications.